Does everybody hear me okay? Yeah? Okay, good. I'm going to stand over here because if I stand back here, you won't be able to see me. So I'm going to stand up here. Plus, I tend to be more animated when I'm not behind the podium, so I don't know if that's a good thing or a bad thing. It's so nice to see the room so full, and I hope that you'll be excited to hear what it is that we're going to talk about today, which is an expedition that we had last year to Cuba. And I just wanted to start out by talking a little bit about why Cuba. And so if you take a look at this map of the area, and especially look at these circulation patterns for water circulation around that area, you can see that kind of Cuba occupies a really central location. So there are currents that are coming in from the Caribbean, going around the western coast of Cuba, and going all the way up into the Gulf of Mexico. And you're also seeing these kind of loops that are going around. And the Florida Keys National Marine Sanctuary is downstream of water currents that are flowing around Cuba. And these water currents may actually be carrying larvae from corals, from sponges. And so the health of these reefs is really important to the health of the reefs in our own National Marine Sanctuary system. And so a few years ago, probably about 5 years ago, sanctuary managers from NOAA started talking with sanctuary managers from Cuba. And in 2015, the representatives from federal agencies in the U.S., from Department of Interior, Department of Commerce, signed an agreement with representatives from Cuban Ministry of Science and Technology, and in particular their marine protected, or their protected areas, to agree to collaborate on studying these ecosystems that are really connected geographically. And in 2015, also, a very important memorandum of understanding was signed, and it established a sister sanctuary relationship between two marine protected areas in Cuba, the Banco de San Antonio and the Guanacabibes National Marine Protected Area, with two protected or marine sanctuaries in the United States. So there's the sister sanctuary relationship now is between the Banco de San Antonio and the Flower Gardens Bank National Marine Sanctuary, all the way up in the northern Gulf of Mexico, and the Guanacabibes protected area sanctuary, and the Florida Keys National Marine Sanctuary here. And I think maybe Josh Voss may have talked about this last year, so you may have already heard this, but there's very strong evidence from the work that Josh Voss and his group have been doing that indicates that, in fact, all the way up here in the northern Gulf of Mexico, there's a linkage with corals all the way down in Belize. So it's not unheard of that larvae are traveling these large distances or maybe hop-skipping along the way. But this area in Cuba has been kind of a black box for a long time. So being able to go there and work there and study these systems is really a high priority. So I think it was last month that Dennis Hanasak gave a presentation at one of these lecture series on Puli Ridge, and so that's an area that's like kind of right in here. So we've been working in the Puli Ridge area that's just adjacent to the Florida Keys National Marine Sanctuary, and it's an area that's proposed to be incorporated into the sanctuary. We've been working there for quite a while and looking at connectivity of the reefs there with reefs all around here as well. And as part of our NOAA Cooperative Institute, Joshua Voss's team has been studying connectivity and looking at coral reef resources in the Flower Gardens Bank, which is right up here. So if you remember, those are the two areas there and there that are part of the sister sanctuary relationship. So we thought, boy, this is a really good opportunity, since we've been studying this for such a long time, really for almost a decade, and we've got funding to expand that work and to be able to put more pieces in that puzzle of the connectivity, to go ahead and plan an expedition to Cuba. And there are many times that John Reed and I thought, oh, what were we thinking? Because it's really hard to mount an expedition. But we decided to go ahead and plan this. It's especially hard to mount an expedition when you're going to a foreign country. And it's especially hard when that foreign country happens to be Cuba. But the stars were in alignment at that time because things were opening up in Cuba. So we were able to go, and there weren't those restrictions that we had prior to this. So my hero in all of this is John Reed. John's in the audience, I know. And this really wouldn't have happened without John. John was the chief scientist on the cruise. And John, I don't know how many emails were exchanged over the course of the year and a half that this was in the planning stages. I would say hundreds, probably close to 1,000. Not between John and me, although there were quite a few of those, but just trying to put all the pieces together. And our counterpart in Cuba is Dr. Patricia Gonzalez, and Patricia is the director of the Center of Marine Research at the University of Havana. So it was really the two of them working together really, really closely to be able to define objectives. What is it that we want to do? How do we start building that trust? Because as you can imagine, once things started opening up in Cuba, everybody wanted to go down there and work. And so the Cuban scientists had to be very, I think, selective in their partners and whom they wanted to start establishing relationships with, who wanted to really go down there and collaborate with them as opposed to going down, studying, coming back, and the Cuban scientists and that research community not benefiting at all from it. So it was really important, and in fact, it took us such a long time because we really had to put all of those pieces together. When you go to a foreign country to do any research, you have to get all kinds of permits, and especially if you're taking a ship there. And even more so if you want to put a remotely operated vehicle underwater in Cuba. Okay, so it involves getting permits from our Department of State, permits from the Cuban Ministry of Science and Technology, and that's just to kind of start this whole process going. Then if we want to collect samples, which I have to tell you, I really didn't think we were going to be allowed to do, you have to get permission to collect samples. And we were requesting to collect samples from protected areas, from sanctuaries. And we wanted to take those samples back with us, or some of those samples back with us to the United States. I really, John and I talked about this many times, and it's like, we're never going to get the permission. We started doing this, and we started, I want to say maybe in January or February of 2016. And our plan was to be able to have the expedition in September, and it just wasn't happening. And so we never got the approval in time. So we kind of reset our clock and decided to keep going with it. And it involved identifying one point of contact and the person or agency in Cuba that was going to be responsible for issuing all these permits. And it turned out that the agency was the Cuban Ministry of Science and Technology. But within the agency, it was their protected areas, and in particular their marine protected areas. And this person, Carlos Diaz, was the one who finally made it all happen. He's the one who ensured that permits were being issued, that the agreement that we had to sign was in place. And there's one other person that I'd be really remiss in, if I didn't acknowledge her, and that's Miriam Campo. Miriam Campo works she's the director of our sponsored research office down in Boca. And Miriam is a Cuban American. She speaks and reads, and thank God, writes Spanish. And it was Miriam who really, I want to say, expedited things when we had to sign this memorandum of agreement with the Cuban government, because we were basically agreeing that we were going to share things jointly, that we designated what exactly our objectives were, what it is that we were allowed to do, what the outcome of that was going to be, who was going to share in that knowledge, who was going to share in any intellectual property if any were developed. And these documents had to be in Spanish and in English, multiple copies. And so we, we were coming down to the wire, I have to tell you, we were really coming down to the wire. It was about a month before we were supposed to leave. And the agreements were not signed yet. And our lawyers were saying, well, Shirley, how can we be sure that what you translated using Google Translate is an accurate representation? I'm not kidding, was an accurate representation of what is in the Spanish version. And it was Miriam, and at that point, they kind of put the brakes on and said, we're going to have to, go get an official translation of this. And it was Miriam who really saved the day, came in, read both versions, said, wow, this is a remarkably good translation, and certified to FAU Legal that it was okay. And really, if it weren't for her at the last minute, we probably still would, those samples would probably still be in Cuba. So I wanted to just thank Miriam because she really was another one of the key players in all of this when we were preparing. One of the other things that really helped us was that in March of 2017, Josh Voss and I went down to Cuba and we met with the representatives from the different agencies. This was while we had been communicating by email, we had never met face to face. And that was the time that we started establishing that relationship. It's not, I mean, in many cases, it's really being able to establish that mutual trust, having some shared objectives, and being able to, have a reasonable assurance that what your partner says, they're going to do, they're going to do. And it was only after that meeting in March of 2017 that things started rolling with the agreement. So, as I said, there are many partners involved. Our Cooperative Institute for Ocean Exploration, Research, and Technology, as Dennis mentioned, is the program here at Harbor Branch FAU through which this project was run. Our partners in the Cooperative Institute are the University of Miami and UNCW, and also SRI, but they were not involved in this expedition. The Cuban Ministry of Science and Technology was a key player, and the National Center for Protected Areas, again, key players. And then the Institute for Marine Science is associated with, it's a government lab associated with SITMA. The National Aquarium of Cuba, also associated with SITMA. And then the University of Havana, where Patricia Gonzalez has her appointment. So that it takes a village, it took a village to get this going. And I will tell you, there were many times that we thought, why are we doing this? Our sponsor is NOAA. NOAA's been sponsoring our Cooperative Institute for the last 9 years. And they continued to sponsor this. And part of the ship time was paid for through a grant, another NOAA grant that went to the University of Miami. So what were our objectives? We wanted to characterize the mesophotic coral ecosystem. So the mesophotic coral ecosystems are kind of like, we call them twilight zone reefs, but really it's just an area of lower light, what we old timers used to, back in the early days that we were all diving, when we first started diving, it's like the deep reef environment. But it goes from about 30 meters to 150 meters, so really deeper than scuba depths, but light penetrates, and there are still corals that have calcified skeletons at that edge. So those are in the mesophotic coral ecosystems. They have not been studied around Cuba at all prior to this expedition, using the ROV operations. So our plan was to, and again, these objectives were mutually agreed upon between our scientists and our Cuban collaborators. And then to document reef fish and commercially important reef species, so that was another important priority for our Cuban collaborators. Being able to understand that connectivity between those ecosystems in Cuba and those in the sister sanctuaries specifically, and then be able to characterize the health of these mesophotic coral ecosystems. So we started out really only planning to go here. And in fact, in the first cruise plan that we submitted back in early 2016, that was what we proposed to do. And then when we went down to Cuba in March of 2017, it may have been actually even before that, the Cubans said, you know what, you're going to have a ship here, you're going to have an ROV here, we've never explored these reefs, we need to go all around the island. And at that point, then John kind of like took several steps backwards and said, okay, now we have to really think about how we're going to do this, because it's, you know, it's a long distance to circumnavigate that whole island. But Cuba is very aggressive in its protected areas, and so they have a lot of protected areas around the island, and they were really interested in seeing what was happening. They know a lot about their shallow reefs all around the island, but not much at all about their mesophotic coral ecosystem. So we stepped back, and again, it was mutually agreed upon, and any of these places where you see red stars are areas where we made dives with a remotely operated vehicle. And any place where you see green stars, I only see one right here, are areas where we snorkeled. Okay, so finally, after all of that negotiation, basically from about February of 2016 to literally a few days before the ship left in May of 2017, we got our visas, we got permission to go. So this was not the first time Harbor Branch scientists have been to Cuba. And so those of you who've been familiar with Harbor Branch for many years might remember that in 1997, so 20 years ago, we actually had an expedition to Cuba using the Seward Johnson and the Johnson Sea Link. And I don't see Grant in the audience, but he's mentioned it just about every single lecture. So Grant Gilmore was the chief scientist for this expedition. And my good friend Al Giddings was a producer and director, basically, of underwater cinematography for a Discovery Channel documentary. So the whole impetus for this expedition was to produce a documentary for the Discovery Channel. It was called Forbidden Depths. And it was a 5-week period of time from beginning of December to beginning of January. And I was extremely fortunate to be able to go on this expedition. Outcomes from the expedition, there was a book that was published by Bill Belleville that chronicled the expedition. 2 DVDs that came out. I was searching because I thought I had extra copies and I was going to kind of like give away a few as a door prize. But anyway, because it's kind of hard to get the DVDs. What really interesting DVDs. And then for me, one of the highlights of my professional career was, after my initial fear of meeting the communist dictator president of a country that almost resulted in World War III when I was 8 years old, getting to actually meet Fidel Castro and having the opportunity to actually talk with him one-on-one for about 25 minutes. And so that was really, I mean, when I look back on my professional career, that was one of the highlights of my career. So it wasn't the first time that Harbor Branch scientists have been to Cuba. Now, unfortunately, the cruise dates of the first ones we proposed were in September of 2016. When we finally got permission, the cruise dates were May, June of 2017, which exactly coincided with when I teach in the Netherlands. So I didn't actually get to go on this expedition. I know, don't worry, I'm gonna go this way. This was a photograph that was taken by our colleagues in Cuba when the Walton Smith, the research vessel Walton Smith, arrived in the port of Havana on the morning of May 16th of 2017. So it was a month-long cruise, and there were a couple people, I think 2 or 3, yeah, at least 3 people, who were on for the entire mission. So John Reed, Chris Diaz, and Stephanie Farrington, I think that's it, were on for the entire mission. And one of the Cuban scientists was on for the entire mission. But typically we divide them up into legs. So the first 2-week leg, this was the crew in the first 2-week leg. So you'll recognize Ming-Shun Zhang, Chris Diaz, John Reed, and Stephanie Farrington. Oh, and Mike Stodovan. By the way, Mike Stodovan is a PhD candidate. He'll be graduating, I guess, this semester. He already defended. The video that you saw right before the lecture was produced by Mike. So it was he did a really nice job with that. And then the second leg looked like they were a lot happier, waving goodbye, I don't know. So you'll recognize again John and Chris and Stephanie and Josh and Dennis, and then also the ROV crew, Jason White and Lance Horn. And then the rest of these folks were our Cuban colleagues who participated. So we divided them up into teams. They're divided in, I guess, self-organized into teams. The algae team is led by Dennis Hanasak here at FAU, and Beatrice or Betty Martinez, who's from the University of Havana. And we call, this is a student, we call her Little Patricia because her name is also Patricia Gonzalez, just like Big Patricia. So this is Little Patricia, and she participated in the expedition. Our sponge team consisted of Chris Diaz, who's in the audience here somewhere, and Lynette Busatil Lopez from Havana, and in spirit, me also, because I'm the sponge person too. So anyway, so that's the sponge team. The coral team is led by Josh Voss and Big Patricia Gonzalez from the University of Havana. And Mike Stodevan was on the cruise, and Julia Gonzalez Mendez was also on the cruise, and of course John Reed is also part of the team coral. And then the fish team, the partners in that are Andy David from NOAA and Felicia Drummond from NOAA, and there's Felicia, not all decked out in her uniform. And Dorca Cobian from the Guanacabibes National Park, and Elaine Garcia Rodriguez from the Institute of Marine Sciences. So those were our four teams. Physical oceanography team, Mingshun Zhang and Jorge Luis Viamontes are the partners in the physical oceanography team. And then this is Dennis Elias, who's a marine technician who works for the University of Miami and was on actually for the entire cruise. And this is a more informal picture of Danielle Estrada from the Marine Research Agency at the Geo-Cuban Marine Studies. This is the crew of the Walton Smith, and another very important person is Rich Bain, who's the Director of Marine Operations and helped us navigate through some issues related to export control as well. So we have to get permission for every single piece of equipment and everything that we take on the cruise that we're taking to Cuba, including down to glass jars. And that goes through FAU, but then once it goes through our export control, it has to go through University of Miami's, and Rich was really helpful with that, as well as helping out with visas. And then I already mentioned our ROV operations crew, Jason White and Lance Horn from the University of North Carolina at Wilmington, their undersea vehicle program. And we've worked with Lance and Jason for many years. So each day, dives were made using the remotely operated vehicle, the Mohawk ROV. It can go down to, I think, 1,000 feet, but we only needed to go to about 450 feet. And this is just a series of photos on the launch of the ROV. And then once the ROV is launched, it's tethered to the surface. And so the teams then started working. They could observe in real time everything that the ROV cameras were imaging. So there was this live ROV video feed to the lab on the ship. And then our specialists entered data on what kind of habitat was there during the dive. And then they had special keyboards that were already programmed. So the algae group had a keyboard that was programmed so that they could, on one click, just enter some of the common species of algae, sponges, corals, and fishes as well. So the ROV has a manipulator arm, a multifunction manipulator arm that has a claw on it to be able to collect samples. And this is just a picture of the claw on the front of the ROV, and here it's clutching a gorgonian that was too big to fit into a collection bucket. And there's also a suction tube to allow us to collect samples by suction as well. And this is the bins into which the samples that are collected are placed. And these are buckets into which samples that are suctioned up using the suction hose are placed. And there's a happy Josh picking up one of the bins that has, looks like a really nice sponge in it, and carrying it into the wet lab. And then in the wet lab, there's this flurry of activity and what we call process the samples. So the samples are sorted, they're labeled, we assign a barcode to each sample, they're photographed, and then they're preserved for different things. So we preserve them for biodiversity studies, so for museum collections, and also for molecular studies as well. All the data and the photos are uploaded into a Microsoft Access database, and that's how we track the samples, the disposition of the samples. There are a lot of physical parameters that were also measured on a daily basis. So things like temperature and salinity and fluorescence and dissolved oxygen are monitored continuously with sensors that are on the ship. And then we can measure current profiles using another instrument that's on the ship. It's called an acoustic Doppler current profiler, ADCP. And we also had sensors on the ROV, actually some really novel sensors to measure pH and PCO2, because we're interested in what's happening in terms of pH changes related to climate change. And they were mounted on the ROV, and then shipboard water collection was done using this thing, which is called a CTD rosette, and collected water samples as well at a few locations, I don't think every day. Okay, so if you kind of remember about that the current circulation model that I showed you before. So here's like that main current that flows off the west coast of Cuba, and then the red arrows kind of indicate like a countercurrent that's flowing around, closer to the coastline. And so based on these current data, Ming Shun and his collaborator in Cuba selected some points where they would be doing some additional monitoring and measurements. And so Ming Shun was only on the first half of the expedition. That's just to remind you about this is what we're interested in, what's going on here that might affect the Flower Gardens Bank and the Florida Keys National Marine Sanctuary. And so what they found was that during leg 1, the currents were running clockwise, and during leg 2, when they were at a different part of the island, the currents were mostly counterclockwise, except in a few areas. And so they were relatively moderate currents, thank goodness, because it would have been difficult to operate the ROV in strong currents. And the data are still being analyzed in terms of the other chemical sensor data. So one of the things that John Reed does on all of our expeditions is he makes these really beautiful drawings that to describe, to illustrate what the bottom looks like. And so here you can see kind of a schematic of the deep 4 reef slope and the mesophotic zone. So again, it goes from about 30 meters to 150 meters. And in that 30 to 50 meter area is what we call the deep fringing reef. And then between 50 and 125 meters is the escarpment or the wall. So this buttress zone in here is between 50 and 80 meters. And you can see kind of like, again, John summarized what are some of the dominant components of these different areas. So, you see corals and gorgonians and sponges and algae up here, and then some shingle-like plates, and then things that are dominant down, all the way down to the deep island slope, which goes between 130 and 150 meters. So I'm going to take you on a dive now and all the rest of these, for this next series of slides. These are slides that John kind of selected best of and put together for a presentation actually a couple presentations that he's made. So here we have 180 plus meters to 125 meters. We're going to see the next few slides on the deep island slope. Now we're seeing a transition where it starts getting steeper in this wall area. And these are lasers that we use to record the size we can for a scale, and they're 10 centimeters, about 4 inches apart. Sponge. This picture is not turned sideways. That's actually the wall, vertical wall. You see all these caves and ledges. Starting to see some lionfish here. Beautiful gorgonians and sponges. More along that wall. Some of these overhanging buttresses now. You can remember it from that diagram. And then we start seeing the zone of dense platy corals called agaricea. This is a big barrel sponge, Zestospongia. Now we're getting in this 50 to 40 meter, the deep fringing reef. So we're starting to get into the area where you could dive, scuba. Here's the reef crest at 30 to 40 meters. And then the back reef area. Okay, so what did we find? Well, we circumnavigated the island, 1,500 nautical miles in 30 days. Never done before. We did 43 ROV dives, so those are the red stars, and 8 snorkel dives, so you can see like these little green stars here, that's where we snorkeled. This was the area I really have always wanted to dive in. Doesn't look like it's gonna happen. And then based on these data, our Cuban colleagues are really, really excited because they're proposing 4 new sites for marine protected areas. So they're already really thinking about, okay, how do we take these data now to and apply it in terms of resource management? These are our statistics. Our maximum depth was 188 meters. We collected almost 700 samples, 94 water samples, and all the rest of those were from ROV and snorkel dives, and they were benthic invertebrates and algae. So far, just from our preliminary analyses, we've got about 600, almost 700 species. John keeps track of how many hours of video we recorded and how many images, how many photos we took. About half of those were during the photo transects that we made. But we also take pictures of all of the samples that we collect in situ and then on the deck as well. So we have almost 500 species of benthic invertebrates and algae that we observed at the dive sites, almost 150 species of fish. And now I'm going to break it down into the four of the groups. So algae, sponges, corals, and fishes. So this next group of slides were provided by Dennis and Betty, Dennis Hanasek and Betty Martinez. So we saw a definite zonation along the Mesophotic area. So from 170 to 75 meters, red and green algae were dominant. When you move up to 100 to 50 meters, you started seeing Halimeda copiosa that was very abundant. And then from 50 to 30 meters, a brown alga called Lobophora variegata was abundant. And then from 30 meters and up, the Dictyotales and Halimeda species were the most common. And so here's some more photographs of some of the algae that were observed at the different depths. So an Anadyomene, fairly deep, Eudodia at 62 meters, Penicillus is this. It's called mermaid shaving brush at 53 meters, and Chrysomenia enteromorpha. Don, if you look, Don, that looks like the one we saw on the Mariana Trench expedition. And then these are some of the algae from the shallow reef. So in terms of algal biodiversity, so far 90 different taxa have been identified, and this is the breakdown. Blue-green algae were observed on 5 dives, and in terms of other notes, the algae team observed seagrass lying on the bottom at the beginning of some of the dives in the deeper areas, and so that would show that connectivity between shallow and deeper systems. But overall, the flora were more similar to Florida than they are to the Bahamas and the Caribbean, which is quite interesting. And then our Cuban colleagues were very excited that they were able to collect algal samples from areas where they had never been snorkeling in shallow water before, particularly around that northeastern area of the island. So part of the agreement that we have with Cuba is that we are going to co-mentor graduate students, and I'll talk a little bit more about that later. But there are 2 PhD students and 2 master's students who are going to be working up these data for their dissertations and theses. Okay, sponges, yay. So those are just laser dots. It's not really a screaming sponge, but I think I'm going to show you a screaming sponge later. But in 3 words, diverse, abundant, and unique. So we're really, really excited about the sponge fauna. So there were 289 species, so different things that look like they're different species that we were able to visually distinguish. Now, with sponges, and probably with some of the crustose algae as well, probably sponges, algae, the sponges, and the corals, really you need to have a physical sample. So just taking photographs, and you've heard me say this a few times before, just having a photograph isn't good enough to get you down to species, and that's especially the case with sponges. So in this situation, we could identify, you can see from this image, there's one species, and there's another one, only because we know this from the work that we've done, and there's another one, and then there's something back there as well. So we're trying to get actually build a photo album for each of the different groups that we've observed visually, and especially those for which we have physical samples. Here's some examples of some of the other sponges that we saw. This was, I can't take credit for this. This is Chris Diaz's sense of humor. But it does look like the screen, doesn't it? So this is a calcareous sponge. And so there are 4 different classes of sponges. And most of the sponges that we found were from the demospongia, but we also found sponges from the calcarea, so they make calcareous spicules instead of siliceous spicules, and from another group as well. We didn't find any, I don't think we found any glass sponges at all. Okay, so we're only able to collect 117 sponge samples. 19 have been identified to the species level, but we're working, actually, and this probably needs to be updated because Chris and Lynette have been working on it since then. But so far, out of the things that they've been working on, we probably have at least 10 new species of sponges. And one of the ones we're really excited about is this sponge called Zestospongia. Well, they called it baby because they thought it was a baby Zestospongia, the barrel sponge that's really common in reef areas throughout the Caribbean and Gulf of Mexico and Bahamas. But upon further examination, it's actually different. So this is what Zestospongia muta looks like. And see, it's got that narrow rim there, whereas this has kind of a rounded rim. So we're very excited about this. We think it's a new species, and we want to do some more work on that and really kind of go back in our records and see, is this something that we've seen in the past in our videos but overlooked it? So our goals are to, of course, discover and report on new species using both molecular systematics and molecular and morphological systematics. And then we have 2 students who are going to be working on their, one on her dissertation and one on her thesis. on ecological study of the mesophotic sponges. And this is really an important baseline for future work that we want to do on mesophotic sponges in the region in general. Okay, and the corals, and this, I neglected to mention that last batch of slides on the sponges were provided by Chris Diaz, and then this next batch of slides on corals were provided by Josh Voss and his team. So again, we see some zonation from the deep coral reef to the lower mesophotic to the upper mesophotic. So in the deep coral reef, these were the things that we found to be most abundant. And in the deep mesophotic from 60 to 125 meters, these were the most abundant species that we saw. And then in the shallow mesophotic from 30 to 60 meters, again, we saw different groups of species that were abundant. So again, a very prominent zonation in these different areas of the mesophotic zone. There was a very low incidence of coral disease overall. And what's going to be happening now for these studies that are currently underway are to look, focusing on one species, because the Montastria cavernosa is the one that Josh and his group have been working on throughout the Caribbean and the Gulf of Mexico, looking at population structure and being able to estimate larval migration. Oops, I have estimates down there twice. And molecular analyses. There are at least 3 PhD students and 2 master students, so 1 PhD student and 1 master student from Cuba, and I think 2 PhD students and a master student from FAU. The fishes, these were the fishes, the reef fish that were found in that area from 100 to 150 meters. And because the Cubans were interested in looking at the commercially important species, especially the groupers, again, these were some of the grouper species that were documented in the mesophotic reefs. So after the cruise, as dictated really by the memorandum of the agreement that we signed, the samples were split, they were divided, and we were able to actually export half of them, and the Cubans kept half. So we're working on them in parallel. We're actually working on them together, and there's been a very close collaboration. So it's not the type of thing, it's like, okay, you do your thing with your corals, and I'm going to do my thing. And no, we're working really closely together. But there were also some post-cruise activities that were planned. So after each leg, the cruise gave seminars and tours to dignitaries, government officials in each leg. And our host, Carlos Diaz, basically hosted a lovely dinner, luncheon and dinner for the participants after each leg. And I will tell you that Carlos is really all of our Cuban collaborators are extremely gracious hosts. We were there, Dennis and Josh and John and Ming-Shun and I, and Chris, were there in December, and to have a follow-up meeting to talk about our data and what are the next steps. And just, these people have become our friends, not only our collaborators, but our friends. So it's a really great relationship that's been established. They're really proud and pleased to be able to participate with us. So I wanted to just share with you a couple of kudos, and these came after the preliminary cruise report that John and Stephanie compiled with input from all of the other collaborators, the US and Cuban collaborators, and they put together an amazing cruise report, which is available on the NOAA website. The link to the website is on the program, so you can check it out if you're interested. And within a day after it was posted, we got a couple of emails, and one of them was from the coordinator for international activities in NOAA's Office of Marine Sanctuaries. And he shared with us that he had met with Carlos Diaz, our host, And Carlos said that the expedition was the most comprehensive exploration of Cuban waters in almost 50 years, and that this was the type of activity that he would like to see repeated in the future. So they really value this collaboration. And the chief scientist for NOAA's National Marine Sanctuaries program, well, you can read it, but basically the bottom line is they recognize that we've accomplished an exceptionally important milestone that establishes a baseline of ecosystem quality at a critical point in Cuba's history. So again, kudos to John for leading this whole effort as well, because he's the one who really puts all of this together and makes it happen. It wouldn't have happened without John, just like most of our expeditions. Okay, next steps. We're working right now on taxonomic identification, revisions. We're putting together photo albums for each of the taxonomic groups. In fact, Chris Diaz is going to Havana on Sunday and spending a couple weeks down there working with our colleague Lynette to put together the photo album and to identify the sponges. So working also on the benthic and fish community analyses. So we're going to be looking at the transect data. John Reed and Stephanie Farrington are going to go down at the end of March to do what's called like point counts to be able to quantify the data from the transects. Josh and his group and Patricia Gonzalez and her group in Cuba are working on molecular analyses to establish connectivity patterns. And as I mentioned, this is an ongoing research collaboration. We're mentoring Cuban graduate students, so I wanted to just tell you a little bit about what's happening with that. The plan was that the Cuban graduate students would be here now. We had apartments reserved for them. I had funding all in place. And then in September, I think it was, because of the problems at the U.S. Embassy in Cuba, a lot of their staff were sent home, and all of the staff responsible for issuing visas were sent home. So now, if a Cuban national wants to get a visa to come to the United States, they still can, but they have to go to another country to get it. Yeah, exactly. So they have to go to Mexico or the Bahamas or anywhere but Cuba. These are people who make about $25 a month. So it's not going to happen unless things change. When we were down there in December, I went to the Cuban embassy and had a meeting with the charge d'affaires. What he told me was that there's going to be an important decision point in March, and at that point, there'll be a decision that'll be made to either ramp up the staff again, which we're hoping is going to happen, but I'm not too optimistic about it, or it'll be what's called an unmanned outpost. So I'm hoping that it's the former and not the latter. Otherwise, we're going to need to be creative about how we get visas for the students to come to the United States, because we would really like them to come either at the, I'm getting ahead of myself. So there are recommendations for protection, expansion of the marine protected areas, but also we're planning to have a follow-up cruise in August, and I am going on that one. That'll be, I think, about 3 weeks long, and we're starting to get the permit application process going. It should be a lot easier. We're taking the same ship, we're taking the same ROV, and we know people now. So they know us, they know that we're good partners, and they want this. The Cubans want this to happen. We actually would not have even proceeded with planning for this if we didn't get a very enthusiastic encouragement, not only from the scientists, but from the Minister of International Relations at the Cuban Ministry of Science and Technology when we were there in December. We're hoping that the students will be able to come right after the expedition, so that would mean we're hoping things are going to work for better in March. And just today, John submitted first manuscript for publication based on the data from the expedition. So this is really exciting, and it's really remarkable that this expedition that happened in May, June, and with the collaborators all working together to put together this manuscript really championed and led by John Reed, has happened in less than a year. This is unheard of. So a big thank you to the US-Cuba team, and especially to my hero, John Reed. And if you want more details about this, mission blogs, photos, videos are all available at that website, and the website is also on the program. So if you want more information, you can get it from that NOAA website. And that's it. I'd be happy to take questions.